Now I'm going to jump down and answer questions 5 through 10. You may notice that I did eliminate question 4. After rereading it, I really didn't like it. I didn't see the point of it, so we're not going to do it. So problem 5 through 10, name the property that is being shown, then find the value of x. So right now I have 8 is equal to 8 plus x. So x has to be something that's not changing the value. So what could that be? What is the only number that I can add to something that doesn't change the value? That value is going to be 8. Let me get my colored pen back. So, or I'm sorry, not 8. That value has to be 0. Whoa. X equals 0 by the additive identity. Question 6, 10 times something is 10. So I'm multiplying 10 by something. That value is not changing. So what is the only number that you can multiply something by to make sure you get that same value? That answer is 1 by the multiplicative identity. And then again, if you remember one-step equations from last year, we can also solve these. If you remember, if this is 8 equals 8 plus x, what is the opposite of adding 8, or what is the opposite of positive 8? We can take our algebraic expression, subtract it from both sides. So then we have 0 on the left and x over here. Same thing here. If I have 10 times x is equal to 10, right now I'm multiplying, so what is the difference, or what is the opposite of multiplying? Dividing. So I would divide both sides by 10, and there you can see you're getting 1 as your answer. So both of those reasonings are because of your identity properties. Question 7, 1/2 times x equals 1/2 times 7. So I have something on the left equaling something on the right. I notice that I have 1/2 showing up on both sides. So if I have to make sure both of my sides are equal, it only makes sense then to go ahead and say, well, x has to be equal to 7. So that's going to create my 7 here. So that's that one really goofy property that we talked about in the beginning. My left side and my right side look identical. So what property allowed me to recognize that I didn't even have to solve anything? I just had to match up my sides. That was my reflexive property. And again, you could go ahead and solve this algebraically. So if you wanted to do that, I'm going to write it up here. I have 1/2 x equals 1/2 times 7. So I recognize that I need to get the x by itself. So right now I'm multiplying x by 1/2. So what is the opposite of multiplying? Dividing. You also want to recognize here that if we're dividing by 1/2, that would be the same as multiplying both sides by 2. So if I multiply by 2 here, multiplicative inverses over on the left. So multiplicative inverses tell me that 2 times 1/2 cancels to 1. So that can go away. And then I also have multiplicative inverses over here. So I can regroup that side using the commutative property, 2 times 1/2 times 7. Use my multiplicative identity to show that 2 times 1/2, those are just multiplicatives. So I can say 1, and then 1 times 7 is just going to be 7 by my, again, multiplicative identity. I misspoke up here, I believe. These are your multiplicative inverses. Multiplying by 1 here is my multiplicative identity, so it's 7. So that's just a longer way to get to the same thing. I multiplied both sides by 2 using my knowledge of opposite operations. That in turn created multiplicative inverses. So on both sides, I could cancel them out. And then I was left with over here multiplying by 1. Or like I said, I could just recognize that these look exactly the same. So if I have 1/2 and 1/2, something else and something else, I knew that something else over here. I know that 7 is just going to be in there because that's my reflexive property telling me that side 1 has to equal side 2. Question 8, 5 times 1/2 is equal to 5. 5 times 1/5 equals x. So I notice right off the bat, my multiplicative inverses over on the left. 5 times 1/5 is 1. So So I get an x value equal to 1 by my multiplicative inverses. Question 9, x plus 3/4 equals 3 plus 3/4. So again, I can do this really quickly like I did number 7. Or if we want to start thinking, how can I solve this algebraically? Well, I know I have to get x by itself, so I have to get rid of this plus 3/4. What is the opposite of adding 3/4 to something? We can subtract 3/4 and subtract 3/4. So right now, by subtracting, I'm getting rid of those two terms. They're canceling to 0. So what property do I know lets me add and subtract opposites to cancel to 0? That is your additive inverse. So I get 0 over here and 0 over here. Or again, you can think in terms of that reflexive property. If both of my sides look exactly the same and I know both of my pieces here, I can just easily say that that missing piece is the same because this side has to look exactly like this side. So x has to equal 3. Finally, number 10, 2 plus 8 equals 8 plus x. Well, I notice that my order is changing, so maybe that's going to look like my commutative property, but let's go ahead and start using some of our properties. So keep in mind that when we're solving equations, we're trying to get x by itself. So if I have positive 8 plus x, how do I get rid of this positive 8? I can cancel numbers out by using additive inverses. So the opposite of 8 is negative 8, and my opposite of 8 here is negative 8. Again, point of doing that is because now I'm combining additive inverses. I know they're always equal to 0. So my 8s all cancel out, and I'm left with 2 is equal to x.